Hi, I'm Dr. Blaise Liffick. This is the Adaptive Computing Lab of the Computer Science Department, and in this lab we do human-computer interaction work, and basically that means we look at how to make systems easier for real people to use. One of the subspecialties that we have in this particular lab is developing systems that are assistive technology for disabled users. And so what I'm going to tell you a little bit about is one of the products that we developed here in the lab and how it's used. At the sort of extreme end of disability are folks who can control perhaps a single muscle that allows them only to activate a single switch. And so this is a typical example of that kind of a switch. It's referred to as a jelly bean. And basically on and off. It's a single bit input, as we typically refer to it as. And you might wonder how anybody can control anything with just that one on-off activity and action. And it's possible actually to control the entire computer in that fashion. It's tedious and time-consuming, but it's possible. What I'm going to show you now isn't how to actually do that control work, but how to test users for where to locate a single switch. Many disabled folks have a variety of locations where we might potentially put it, but we need a systematic way of testing those locations. In addition, this isn't the only kind of switch possible. For instance, here are a couple of other switch varieties that we might try. This one on a little visor here is a switch that might be activated with an eyebrow, for instance. This one is a sound-activated switch, and so we might put it in front of their face, and they can make any kind of sound whatsoever to activate it. This one is an infrared that detects motion, and so we can actually position it up by their cheek muscle, and if they can just, sort of wink, it can detect that. We didn't develop any of these switches. What we've developed is some software to test how to place those switches and select the switches themselves. So one of the ways that we did this development was to actually modify a standard mouse to include two inputs. And the inputs will accept a standard jelly bean style switch. And basically what I've done is wired this input to the mouse button so that activating this switch is equivalent to activating the mouse button. And we've got a little test software that when we run it will run the user through a series of trials where we test to see how quickly they can activate the switch, because speed is really important for being able to do this. So it's just a simple enough, we activate the switch, it gives us a signal to do a click, and we press it, and it will then go on to another trial, and we do this about 10 times, and it takes an average. And I'll just quickly go through the rest of these so that we can sort of get on to the results. The purpose of this is obviously not to sit here with your hand and activate it, but actually place it, for instance, by your knee, or activate it with a head motion of some sort. And here what we've seen is the results are the average response time was a little over 1 second. The fastest response was about 1/100th of a second, and the slowest response was nearly 4 seconds. Now what that's going to tell us is when we have positioned this switch in a particular location, we would then move the switch to a new location and run the trials again, and then compare the results to select which position the user can most accurately and quickly activate the switch in. There's more than one kind of test. That was an activation test. There's also a release test, and basically this is the opposite. The idea here is they need to hold on to the button and release it in order for the trial to, there we go, in order to pass the trial. And this is judging basically the other type of muscle control, and that's release. So that's the sort of thing that we do in this lab, and we've dealt with quite a few folks with disabilities. This software is made available through the AAC Institute, for instance, for free download, and we're doing really exciting stuff, I think.